WPR number 3. Question 1, a quadratic inequality. Need to move all the terms over to the left-hand side so that I can factor this. And just for a moment, I'm going to set it equal to 0, which allows me to find these two critical values that I'll put on the number line. Now we know that this problem is an OR problem because of the greater than symbol, and we know from our work in class that ORs give us this shape. So the values greater than 5, in addition to the values less than -2, would be the solutions to this inequality. We could also write this using inequality symbols as x is less than -2 or x is greater than 5. When dividing two radicals, we can divide the radicands and put the result under the same radical. And so in this problem we would have 108 divided by 6, which is 18. X to the 5th divided by x is x to the 4th. And y to the 8th divided by y to the 5th is y cubed. Now, the 18 can be broken into a 9 and a 2. I like that because 9 is a perfect square. X to the 4th is also a perfect square. Remember that when we're taking the square root of a variable, we cut the exponent in half. That means y cubed is not a perfect square, so the technique we use when we have an odd exponent on a variable is we break it down into y to the 1 and the remainder, which is y squared. And so as I go through this, I see I have this as a perfect square, this is a perfect square, and this is a perfect square, and they come out. So I'd have 3x squared y, the other terms stay inside. This is a higher order polynomial, and almost always when we're doing these, we factor the first two terms using GCF and the second two terms using GCF. This is also known as factoring by grouping. So from the first two terms, I have a greatest common factor of 4x squared, and when I divide the 8x cubed and the 4x squared by the 4x squared, the result is 2x plus 1. Now in the second two terms, I have a negative out front, and when I have that, I will factor out that negative, and from the 18x and the 9, I will also factor out a 9. Now when I divide negative 18x by negative 9, I would get 2x, and when I divide negative 9 by negative 9, I would get plus 1. This is a good sign that these match. This is a term and this is a term. They have a factor in common. So from those two terms, I'm going to factor out that greatest common factor of 2x plus 1, and when I divide this by 2x plus 1, I'm left with 4x squared, and when I divide this by 2x plus 1, I'm left with minus 9. Now these are still equal to 0, and when you have two factors being multiplied and you have a product of 0, you can set each factor equal to 0. So here I would have x equals negative 1/2, and here if I take the square root, I would have plus or minus 3/2 because the square root of 9 is 3 and the square root of 4 is 2. So my answers are negative 1/2 and positive and negative 3/2. When dividing, I'm going to KCF, that's keep, change, flip, and as I do so, I'm going to factor. So I'm keeping the first fraction and factoring the 2x minus 8, taking out a GCF of 2, I'm left with x minus 4. In the denominator, that's a trinomial, x plus 4, x minus 3. I'm going to change, there's the change, I'm changing the division to multiplication, and I'm going to flip, so that 20 minus 5x is going to the denominator, and I'm going to factor out a GCF of 5. Now I need to factor the 2x squared minus 5x minus 3. Using tricky trinomial, I'd multiply the leading coefficient of 2 by the constant of 3, and I would list my factors, 1 and 6, 2 and 3. I could use a positive 1 and a negative 6 to make a negative 5, or I could use a negative 2 and a negative 3 to make a negative 5, but only one of those is right, so I'm going to guess and check. I'm going to guess plus 1x minus 6x, and from the first two terms I can factor out an x. from the second two terms, I can factor out a -3. The fact that the 2x plus 1's match means I can then factor a 2x plus 1 out of each of those, and I got lucky. I did it right on the first try. 2x plus 1, x minus 3. Now I'm going to go ahead and I'm going to do some reducing here. So let's see, the x minus 3's reduce. These 4 minus x's reduce, leaving me a -1 because they are switched around a negative. That's the -1 technique. So it looks like I'm left with -2 times 2x plus 1 over 5 times x plus 4. With this fractional equation, I'm going to make sure all the denominators are factored. I also like to add the opposite to get rid of that subtraction. And one other thing I can do is, I see here that I have a 3 minus x. I don't like that. I like it as x minus 3, but when I flip those terms around the negative, that creates a -1 technique situation. So I can flip the 3 minus x and change it into an x minus 3, but I have to put that -1 somewhere. I'm going to put it right on top. So this problem becomes 1 over x plus 3 plus 2 over x minus 3 equals 4 over x plus 3 times x minus 3. And when I look at the denominators, I realize I will need to multiply by an x plus 3 and an x minus 3 to get rid of this and both of those. So I'm going to go ahead and multiply by my x plus 3, x minus 3 on each of these terms. And so now these reduce, and both of these reduce, leaving me with 1 times x minus 3 plus 2 times x minus 3 equals 4. Cleaning this up, 3x plus 3 equals 4, or 3x equals 1, or x equals 1/3. Check out the work here on using the quadratic formula. On the next slide, I'll show you how to solve this quadratic equation using the method known as completing the square. When completing the square, the leading coefficient must be 1, so I'm going to divide everything by a 2. Next, you would clear out any constants and create a space for adding a value to each side. We're going to take half of this and multiply it by itself. So half of -6 is -3, squared is 9. This creates what we know as, or what we call, a perfect square trinomial on the left. On the right, it creates 7. Another way to write x minus 3 times x minus 3 is x minus 3 squared. And to solve this, I would take the square root of each side, giving me plus or minus square root of 7 on the right. Lastly, when I add 3, I would have 3 plus or minus square root of 7, which is the same answer I got when I used the quadratic formula. To rationalize, I'll multiply the numerator and the denominator by the conjugate. This can be reduced. The 20, the 4, and the 12, each of those have a greatest common factor of 4. I'll divide each of them by 4. 5 plus radical 13 over 3.